Hello, everyone, and welcome to section 2.2 of statistics, where we will talk about bar graphs, pie charts, and time series graphs. So, if you remember from section 2.1, we talked about histograms, and we learned that histograms provide a useful display of the distribution of data. However, the data must be quantitative. So now we're going to look at other types of graphs, some of which are suitable for qualitative or categorical data as well. So we've got this first example here, and these data are from Forbes from 1995. And a couple years ago, I remember thinking, well, 1995, that's getting kind of old. And I decided to go look online and see if they had some newer data. And they did. I found it on the Forbes website. They had data, you don't really need to know this, but it was from 2003. And again, this is only a couple years ago. And I was thinking, okay, well, it's newer, so I'll click that to get that data. And then it said that'll be $10. I'm thinking, $10 for data that's this old? $10? So maybe if it were like 2015 data for $10, but 2003 data for $10, so that's what we're still using 1995 data. So in 1995, we have the highest college degree obtained for the 25 best paid CEOs. So we got a small little table here, and what we're going to do is take this information and display it in a bar graph. Okay, so this will be a pretty easy one. There's only these 4 items. And so talking about bar graphs, which everyone has seen before, these can be used to display quantitative or who knows what we're going to write right here. Quantitative or qualitative, right? And just to quickly review from section 1.1, quantitative data. These are data that have a value or numerical measurement for which operations such as addition or averaging make sense. So if you can take the mean of all the numbers, generally speaking, that's quantitative data. Qualitative or categorical data, this is used when you're going to describe an individual by placing the individual into a category or group. Easiest one is like if you're going to categorize the color of all the students' cars, you use qualitative. That would be qualitative data. Okay, so for features of bar graphs, the bars can be vertical or horizontal. Doesn't matter, whichever way you want to do it is fine. Bars of uniform width and are uniformly spaced. This is important because remember we want to display information with our graph. So we don't want to have something like, you don't want to have a bar graph that goes like this, where you have this bar here, and then you have this bar, and it's like you're trying to show information here. This just makes it confusing because typically the height of the bar is going to just show how much of something there is. So when you have it like this, your eye kind of sees the area of this is bigger, so it just makes it confusing. So you definitely don't want to do something like that. So you want to have the bars uniform width, uniformly spaced. So notice space, so they're not going to touch. In a histogram, the bars touch because in a histogram, this is an actual number line. Right, in a bar graph, it may or may not be a number line. So we want to use this convention where when we're making a bar graph, we don't want the bars to touch. And of course, all of these many of you later will be employed and working and underworked and overpaid, of course, right? And then your company or firm will have their own conventions about how they do this. But for now, for us, let's just stick to these conventions. The length of the bar represents the values of the variable being displayed, right? The taller the bar here, the more of whatever this thing is that we have. And the graph should have a title. So we're always going to want to put a title up here. Both axes should be labeled, so we want to show what these are for the horizontal axis, and the vertical axis show typically how much or a percentage or something. And the vertical axis should have scale markings. So there'll be scale markings here on the vertical axis. And of course, there's some exceptions to that, but just generally speaking, that's what we want. So what we're going to do with this bar graph right here is we are going to take a look at these data here and display them graphically down here. So what I'm going to do, I'm just going to put them right in order. So we'll have frequency. So for us, we'll have this vertical axis will be frequency, and we just have to cover the highest frequency that we've got, which is 11, right? There's 11 of those people had a bachelor's degree, so we need to make this go to at least 11. So I think what I will do, just to make it easy, I'm just going to make it go to 12 because that makes it easy. So have 12 here. Makes it easy. I mean, when you're graphing these by hand is what I mean. So you have 6, then you can go 2, 4, 6, 8, 10, 12. Okay, so you don't have to do it just like this. You just have to make sure that 11 can be shown on there. And then the horizontal axis, I'm going to talk about the degrees. So there's 5 who had a doctorate degree. Again, I'm just going in order. You don't have to. So I'm just going to make a bar starting here. That goes to 5. And then whatever width I use for this bar, I'm just going to use the same width for the next bar. So let's see, the next one is a master's degree with 7. So go up to here to 7. So try to keep the bar width about the same. And the spacing here, so whatever space I use here, I want to be consistent here. Again, we're doing this by hand, so they won't be perfect, but we can make them pretty good. And then we've got the next category, bachelor's, has 11. So to come up here to 11. And then the nuns, there are 2 of those. Okay, so then we have to put, we have to label this, so we should say what these are. So the way I'm going to write doctorate right here, but sometimes you'll see, if you see a graph that's professionally done, sometimes in a case like this, they'll sometimes write doctorate off like at a slant here. All right, so there's different ways to do this. Since I'm doing it by hand, it might be a little tight, but I'm just going to write these. So we have got doctorate. We've got masters. We've got bachelors. And we've got none. So we should, of course, say for here, I'm just going to write frequency. And then over here, I'll just give a little more information over here as to what this is. I'm just going to write highest degree obtained. So I'll write that down here. And there's different ways to do this. What I could have done is these words here, highest degree obtained, I could have put that in the title also, right? So these are not written in stone. We just have to make sure that we want to convey information. So we want to make it so that if somebody looks at this graph, they know exactly what we're talking about. So the title up here, I'm just going to add, I'm just going to write 25 best paid CEOs, 1995. So this thing is the title, right? We've got this title here. The vertical axis is labeled and it's got the scale markings. Horizontal axis is labeled. And like I said, some of you may have put the highest degree obtained up here. You may have put in your title, highest degree obtained by 25 best paid CEOs, 1995. So you can put that up there too. As long as when somebody looks here, want it to be easy for them to interpret, right? And so that we're making a picture of our data that is easy to understand. Okay, so that is a bar graph. This is bars that are vertical. We could have also done it horizontal, right? It's just whatever your preference is. And then I'll make a little note here. Let me make a couple of notes here. Okay, I'll make one note. When we're making these, one note is the bars don't touch. Right, so the bars are not touching like they did in a histogram. Also, don't forget a title. Don't forget a title. And sometimes I emphasize this so much that students will do this and guess what they write? Instead of this, they just write title. Okay, that's not what we want. We don't want this to say title. We want to have a title, but we want it to not be called title. Right? We want it to be called something meaningful. So we don't want to write title here. Okay. So that should take care of bar graphs. So unlike a histogram, they are much easier to make. So something closely related to a bar graph is what's called a cluster bar graph. This is an example of one. This is real data. This is from FICO, which you can associate with the credit score. And one thing you'll notice that I thought was interesting when I saw this, you can see that as people age, their credit tends to go up. So these FICO scores, I believe it's starts at like 350, although this goes to 300. But I think it's like 350 to 850 is a credit score. But you can see as you age, one of the factors that's taken into account is the length of credit. The length of time you've had credit established, so that's a big one. So as you get older, you tend to have better credit. One thing I'll mention to you that I didn't know really much about when I was younger, when I was a college student, definitely. Back in those days, you could basically just walking around on campus, there would be people who would hand out T-shirts or pop or something like that, as long as you just sign up for a credit card, and they're pretty much giving them away. And a lot of us got into some trouble with our credit when we were younger. So one thing that I'll tell you though, man, you really want to stay on top of your credit because it's just used all over the place. And if you have a good credit score, life is just plain easier. Things are easier for you. You get better opportunities. You get your loan amount, your interest rates on loans, which makes a huge difference. It's really hard to emphasize how big of a difference it can make and how long it takes you to pay things off. It's all tied to your credit. Even car insurance was, up until just recently, I think in Michigan, the new law that just came out, or is going to come out, July 1st, I think, where credit score, I believe, is not going to be considered anymore. But just generally speaking, as soon as you can, get on top of your credit. It's really important. So But this is an example of a cluster bar graph. So you can see that they put these related, it's a bar graph, but each bar is broken up into different groups. So each one of these bars for each of these credit score ranges is broken up by age. So this is an example of a cluster bar graph. This one is from using real data. And now let's take a look at one, how to make one of these. So let's say for this example that you are a sales manager and you want to show your monthly sales by region. So let's say you've got, for instance, January sales, but you've got 4 regions. And then February sales for the 4 regions, and March sales, and so forth. So each one of these months you want to have it broken up by region, right? So it'd be perfect for a cluster bar graph. So let's say you've got your sales figures along here. And I'll just put some marks in here. So we've got 1, 2, 3, 4, 5. Let's say this is your sales. Hopefully not in dollars. Maybe we could have millions, billions, trillions, dozens, whatever you want. Let's go with millions. So you got your sales in millions of dollars. And then over here, let's say you've got your January sales by region, and they go like this. There's north, south, you've got your east region, and west, something like this. So you've got north, south, east, west, and this is January sales. Then you've got February sales. Let's say sales are looking better in February for most regions. Let's say the west did much better here. So north, south, east, west. This is February. Here's one little known fact about when you're teaching. That happens when you're teaching a class and I draw like something like this. I draw on the whiteboard. It's really weird how these things happen in your mind. Whenever I draw this in class, I'm thinking, I don't want it to look like somebody's like a middle finger. Isn't that weird? Like, why would you think that? But sometimes you draw things on the board and weird things happen. So, and I think it all stems from when I first started teaching. I was in a calculus class and I tried to draw a picture of a rocket ship on the whiteboard and it went really bad. And ever since I'm a little paranoid. So, I don't know, maybe it's just me, but I'm always a little careful about drawing pictures. So, okay, to top it off, we've got our title. Remember, this is called a title, right? But remember, we're never going to name it title. Don't name it title. But we want to have a title. We've got our sales here, and so I'll just stop after January and February, but you can kind of get the picture. This is a cluster bar graph. It's a bar graph, but we've got these little related values that we want to show here. Okay, so this cluster bar graph, you'll probably have 1 or 2 of those in the homework to work on. And then we've got pie charts. Our book calls these circle graphs, but pretty much everybody calls them pie graphs or pie charts. You're going to find out that really what we should do is avoid these. Our author doesn't mention this, but these are, there's been a lot of criticism about these because it's been shown that they're difficult to interpret. So I'll just give you a little example. If you have, there's been more than one, but I'm thinking of one pretty big study that was done. It was just asking people to interpret graphs and seeing what would happen. Now, these are terrible circles, but imagine this is a circle. Actually, let me just do the first one. So let's say we've got this circle, and you do this, and you ask somebody, what percentage of this circle is shaded? Almost everybody's going to say 25%. And let's say it is 25%. So you just have, this little sector cut out. If you ask what percent is shaded, almost everybody's going to say 25% is shaded. Now, if I take this same exact figure and I don't do anything other than just rotate it slightly. So now let's say we have this circle, same circle. But I don't have this set up perfectly horizontal, perfectly vertical. I just have it a little different. So maybe it's like this or something. And then you ask what percent is shaded. Well, then you get answers all over the place. So it's been shown that these are harder to interpret than we think. And even though there's a higher level of confidence in your interpretation, there's also a higher level of error. So researchers have basically been saying to avoid these for at least 100 years, but they're used all the time. So we have to know how to read them because they're everywhere. But if you're going to show data and you don't want it to be misinterpreted, it's best to avoid these. Some other reasons we'll talk about too. And now you've even seen what they have is these three-dimensional versions, which makes it even more misleading. And you've probably seen them. They look nice. It'll be even something like this, but it'll be raised and it'll be shaded, or it'll show like gloss, like a shine to it. So it's 3 dimensions. It looks nice, but that introduces more error. So anyway, we'll talk about these because they're definitely out there everywhere. So in a circle graph, or as we typically call it, a pie graph, wedges of a circle visually display proportional parts of the total population that share a common characteristic. Circle graphs work well. I kind of hesitate to use this word well, but they work with qualitative data is the key here. So usually when you see them, it's for qualitative data. Now, to draw one of these by hand is an absolute nightmare because you have to go through, well, I'll show you. We'll pretend we were going to draw one of these by hand. So, I'm not going to ever ask you to, but if we had to draw one by hand, we have to go through a little bit of math here. We have to say, okay, now first we have to notice that in a circle there are 360 degrees. So that 360 degrees has to correspond to 100% of the data. So we have to translate that. So we've got this percent of the data times 360 equals degrees. Okay, so a little note here is the circle graph must total 100%, right? It's got to display 100% of the data. So just to get an idea, let's say you were going to make this by hand and you're going to figure out master's degree, right? You want to figure out the master's degree. So what you would have to do to just go through this math up here, let's do this one. So let's say we're going to figure out the master's degree. So we've got this little scratch work here, master's degree. We say, well, there were 7 of those degrees out of 25, right? There were 7 master's degrees, or 25, right? It was the 25 best paid CEOs. So 7 out of 25 of them had a master's degree. If you go 7 divided by 25, that gives you 0.28. Or in other words, 28%. Right, so a lot of times what you'll see out here would be the 28% here. But the hard part, if you're doing this by hand, is figuring out what angle 28% corresponds to. So here's where it gets real fun. You take your percent, multiply by 360. That's how many degrees you're going to need right here. So what we would have to do is take this 0.28, right? If you're going to work with a percentage, you typically write it as a decimal. All right, so remember, to get from a decimal to a percent, you move it twice to the right. Just like in Michigan, we have 6% sales tax, 0.06 corresponds to 6%. So from a decimal to a fraction is 2 decimal points, because really a percent means out of 100, so you're essentially dividing by 100. So to go in the other way, you'd have to multiply by 100 to go in the other direction. So then we take this 0.28, we multiply by 360, and that's going to give us 100.8 degrees. So then you can imagine how fun this is to get your protractor out and measure 100.8 degrees, right, to get that. And then you have to repeat it for each of these, and it gets really messy. So they're really not done that by hand very often. I'm just going to fill in these percentages here, because a lot of times you will see this on the bar graph. And all it means is that, the 28% of those CEOs had a master's degree. So you look over here, you can already see some things that would not maybe be good here. If you are colorblind, then this is not going to be good. And if you shade it, how many of these can you have before it starts to get difficult to show various shades? Also, if you don't put these on the side, if you have 8% over here and then somewhere over here there's 10%, you really can't tell. It's too difficult to show. And also, by the time I put this up here, I might as well just have it in a table. So another criticism is your eyes are always going back and forth here, back and forth. Okay, here's bachelor's, where's that? Here's none, where's that? So, all right. But anyway, notice that we do have a title here, right? We've got our title right here. And I'll give you a quote. John Tukey, who was one of the statisticians, pretty much lived through the 1900s, but he's one of the influencers who put a lot of the pieces together that we study now in our first year stats class. And this is a quote that he said about these pie graphs. He said, "There is no data that can be displayed in a pie chart that cannot be displayed better in some other type of chart." So this was probably, mid-century when he was talking that way. And it hasn't changed. There's a lot of criticism of these. But as I mentioned, they are everywhere, so we have to be aware of them. So some of that more criticism is down here. So more stuff we were just talking about here. Many experts recommend avoiding them, pointing out that research has shown it's difficult to compare different sections of a pie chart or compare data across different pie charts. Okay, so a Pareto chart, this is something that you will probably see from time to time. You probably have seen them, even if you didn't know what the name of these were. And all this is a bar graph, but it's done in a particular way. So Pareto chart is a bar graph in which the bar height indicates frequency of an event. Okay, nothing new here. If I just say frequency of an event, basically it's a bar graph, but here's where it changes, and in which the bars are arranged from left to right in decreasing height. The purpose of a Pareto chart is to highlight the most important among a typically large set of factors. And quality control, this is actually where I actually saw them first. In quality control, it often represents the most common sources of defects, the highest occurring type of defect, or the most frequent reason for customer complaints. So a long time ago, I had a job in manufacturing, and the CEO would come in and give us these talks, and this guy was super funny. But he would use these Pareto charts, and he had, this is for scrap. Just an example I'm just going to give you where this is used. And we had these various reasons here for scrap, and scrap was just bad parts that had to be just completely thrown out. So it's basically just wasted money. So you'd have the dollar amount here and you have scrap here. And the reason a Pareto chart works so well is because he would talk about where these were coming from, and then he'd maybe mention that we were spending a lot of time here. So we're spending all this time over here trying to limit scrap for this cause of scrap, when really we've got these two giants over here. So Pareto chart made it really clear. So that's where they're used quite a bit, like quality control. And one of the problems that I developed at that place was when he would do these presentations, he would always use PowerPoint. And this was when PowerPoint was a new thing. So the way he would use PowerPoint, he'd give us these presentations, and the guy was hilarious. His PowerPoints were great. And so unfortunately for me, I started thinking, wow, PowerPoint, every PowerPoint presentation is going to be awesome and super funny. And that's what I was thinking when I went to my first meeting here at the college. And I can remember we had a faculty meeting, and we're sitting in there, and I see this computer fire up, and I see PowerPoint. I'm thinking, oh my God, this is going to be great. Well, that's when I found out not all PowerPoint presentations are the same. So while the CEO of the firm that I worked at tried to make us laugh because I think he liked people, I found out that some people try to make you suffer with their PowerPoint. That's what I found out. Some people who make PowerPoints, they hate people. That's what I found out. And their PowerPoints make you suffer, make you want to cry, and there's nothing you can do. You just have to watch it. So anyway, hopefully for some of you who have PowerPoints in your classes, I hope they're less painful. But anyway, this is just an example of a Pareto chart. And we've got another one to look at here. This is one from some, let's see, what is this from? This is from a customer survey completed by Rough Skins Jeans Company in a Pareto chart. So this is from semi-real data, I'll say. So this company was seeing a steady decline in business, and the company thought it was due to the customer dissatisfaction with the clothing line they were selling, and they were kind of leaning towards blaming the supply chain. But after the survey, they found that the sales decline had little to do with the supply chain. It was mainly parking difficulties, which if you've been a student at GRCC, you may be able to relate to that one, because the college has been struggling with parking for at least a half a century. But you can see that they've got them listed in order here, and then when you put them in a Pareto chart, then it makes it easy to see, okay, this is our number one problem. So a lot of times you can take your resources and try to focus on the big problems. And if you have other resources over here, you could maybe move those over to try to tackle these. So again, we've got a title. The vertical axis is labeled, horizontal axis is labeled, and it makes it really easy, right? I mean, anybody can look at this and see what we're talking about. So that's what we want when we make these. We want to make it really easy to read. So one more graph we need to look at in this section is what's called a time series graph. And these are used quite often in medicine, finance, in physics. So if you've taken physics, or if you will, a lot of times in physics, this horizontal axis will be time. So it's by definition a time series graph. And it's just where data are plotted in order of occurrence at regular time intervals over a period of time. So you may be tracking a particle's position in time like this. Or, of course, in finance, you see them all the time, right? You watch the stock market, and it's going through its changes and so forth by the month or by the year. It's time series graph. So the one that we're going to look at is on page 68, number 14, and it's right here. And what we're going to do, just to get introduced to the calculator, is to use the calculator for this one. On this one's, it's easy enough to do by hand also, but I just want to get us a little practice just using the calculator. So we need basically all this data input. So this bottom part here is actually just carries over from here. So we've got the age here, 0.5 years, and then 1 through 14 basically. So this is talking about the average height for boys. And most likely talking about the mean height for boys as they get older. And so you've got the heights here in inches. So we need to put in our calculator, what we're going to do is we're going to use what's called list 1 for the age. So we need all of this, right? 1, 2, 3, 4, 7, and then 8 to 14. We'll put that for the age. So we're going to put that in list 1. So the age will go in list 1. It's just one list of numbers. You'll know what I mean by list 1 when I show you on the calculator. And the height, we're going to put that in list 2. So the height will go in list 2. And remember, it's important. This is just these, even though it looks like there's 2 tables here, there's really just one. It's too long to put in the book from basically 0.5 to 14, so they put it in 2 spots, right? So in list 1, in the calculator, we're going to go 0.5, 1, 2, 3, all the way to 14. In list 2, we're going to start with 26, 29, all the way to 62. So let's watch this video, which will walk you through how to set this up on your calculator. Before you watch the video, I just realized that number one, it's really shaky. Sorry about that. I was holding my phone with one hand while I was making the video, so it's kind of wiggly. And then also when I'm talking in the video, I mentioned that Y is the age, but really it isn't. When you hear that, I should say Y is the height. We're going to input our X values, so it will be the age, and the Y value will be the height. So we are going to work on number 14 on page 68. So from your calculator, let's first go to the Y equals key. Hit Y equals, and if there's anything in there like there is here, we need to press clear to get rid of it. So I want to press the clear button, get rid of that. And then you notice that I have this plot highlighted. I want to unhighlight that. So to do that, you move the cursor up to that plot, then hit enter, and then come on back down. And so what we want to do is get to the list so we can put the data in a list. So if you ever want to get back to the home screen, just press the second button and then quit. That brings you back to the home screen. So now we need to press the stat button, and then we hit enter, and then we have these 2 lists here, and they already have information in them. So you need to go to get rid of the information. You could just hit delete a bunch of times, but it's easier to go up to the name of the list, hit clear, and then enter. And over here, same thing, go clear, enter. And then for list 1, I want to just put all those data values in there. So it starts with 0.5, and it goes all the way to 14. So I just keep typing all the way to 14. Then go over to list 2, and I put the measurements in there. So it goes for 26, 29, 33, 36. I'm just reading these right off the table in the book. 39, 42. And we got to make sure these correspond correctly. So the 6 corresponds to the 45. And we just keep on going. 62. So if you look at the bottom here, we need to make sure that they have the same number of data points in them. So 14 corresponds to 62. If they don't line up, that means something's missing and your calculator is going to give you an error. And also, if you're unfamiliar with the TI-83 or 84 calculator, just go to YouTube. There are just hundreds of videos that will introduce you to it, and it's really user-friendly. So to get out of there, you can once again do second quit to get out. And now we need to plot these on a graph. So what we need to do is go above the y equals, it says stat plot. So we want to do that. So we go second y equals, and it says stat plot off. We hit enter on that. I'm going to press the enter key. So hit enter, and then I need to turn it on. So I hit enter again. See how the off is highlighted right now? I hit on. And what we want to do is go to the second graph. So go down to type. And these are just different types of graphs. You want the second one, which is going to connect all of our dots. So we hit enter. And then see how down here it says X list, list 1, Y list, list 2. It's basically saying it's going to look for our X values, which is the age in list 1. It's looking for our Y values, which is the height in list 2. So make sure it says L1, L2. And if not, if you need to change that, the L values are here above the numbers. So you just have to hit second and then one of these to get to the list values. Then the mark, it's just going to use this symbol for every data point. Okay, so we're going to make this grid. We're going to have a x-axis, which will be the ages, and a y-axis, which will be the heights. So because of that, we're going to have to make sure our window works. So we want to hit the window key, hit this window key. And the x values, we need to go, it's got to cover 0.5 to 14 for the ages. So just to make it simple, I'm going to go 0 to 15, just to make sure I cover everything. And then the X scale means how often do you want to put a tick mark. I'm going to put a tick mark every 1 unit. So it'll tick at, show marks at 1, 2, 3, 4, and so forth. Now the Y, this is the age. I'm just going to go, see the highest we've got, the biggest number we've got is 62. I'll just probably go 0 to 65. So the minimum I'm going to go 0. Maximum 65. And the Y scale is again a tick mark. I'm going to put a tick mark every 5 units. Because if you go every 1 unit, it's just going to look like there's 2 lines because the pixels will be too close together. So I'm going to go every 5. Then from there, if you hit graph, we get our data. So we've got the ages here, the heights here, and I'm basically going to draw this on our handout. So, and then I'll add in the details here. So if you don't get this, just watch the video again and be real careful. Again, make sure when you go to Y equals, make sure that's all cleared out. Sometimes people will have things way down here and it messes up their graph, so make sure those are all cleared out. And we just want to have the one, that plot is on now because we turned it on. So if you get confused or something's not right, just send me an email and let me know. So after that number 14 on the calculator, we have this graph here. So if we were going to plot this by hand just to see what we would get, I'm just going to kind of draw right over this. So we would have, let's see, right here we would have our x-axis, or sorry, our y-axis. We'd have our x-axis, and this would be the age over here, right? So we'd have age here, and then we would have, these tick marks go by year. So the way that I did it, I went 0 to 15, so we'd have like 2, 4, 6, 8, 10, 12, 14. So I'm just using this calculator as a backdrop, so it makes it easier to do this. So we'd have the age here, and that would be in years. And then our vertical axis is the height in inches, so we'd have to label that, right? So we'd have height. Well, actually, let me make a little bit more room there. So we would have height here in inches. And then the way that we did this, we went from 0 to 65 by 5. So this would be like 10, 20, 30, 40, 50, 60. So we would have this. And then there's only one more thing we need, right? What's the last thing we need? A title. But what do we not call it? Title. So the last thing we would need is a title, which I would just put average height for boys. Or something along those lines, right? So that it makes it easy to tell what we are looking at. So then when we remove the calculator, we have our graph that looks like this. So it's a time series graph, and just basically wanted to do that one on the calculator to get an introduction to the calculator. And remember, make sure you play around with the calculator a little bit so you can get it figured out. So we got a couple of other things here. Which graph should you use? When you get a chance, take a look at this on page 64. And then I've got a little comic here, which I'm sure we've all been here before, right? I mean, seriously, somebody doesn't label their axes. Are you really going to be able to hang around with that person? Probably not. So anyway, that should get you in pretty good shape for 2.2, but there are a couple of handouts that I usually also mention because they have to do with some graphing issues. So let's take a look at those. So this first one just shows some different ways of looking at data, and these data are from the 2010 census. Most populated cities in Michigan. So you can see the listing here. Now these numbers, you may think they seem a little small. These are just in the actual city limits for these places. So in the Detroit region, there's around 6 million people. In the Grand Rapids region, there's about 1 million people. And those regions are named like Detroit Metro, I believe, Grand Rapids Metro. But just in the city limits, these are the numbers. Detroit's a little interesting because the population in the city limits was around 2 million in the 1950s. In fact, in 1950, Detroit was the 4th largest city in the country. And now it's about the 25th largest or so. The population has declined for the past 60 years. In fact, it's the 2nd largest population decline in the country behind St. Louis. But it's still the largest city in Michigan. It's still a big city. So you can see the numbers here. And then these graphs are all created by Excel, or both created by Excel. So you can see that this next one here, we've got a bar graph, which is also a Pareto chart. Right, if you remember the Pareto chart, the only difference is a Pareto chart is a bar graph in order, right, from the highest to the lowest. So it's pretty easy to see here. I mean, some of these are a little close where it's hard, but you can use this first line to get a gauge. So it's kind of easy to see the information here. Now, remember we were criticizing pie charts for a good reason. You can see now it's, even with the colors, that makes it easier. It's still, without these numbers here, it'd be pretty worthless for these, and you can't really get a good gauge. So by the time you're looking at the color, trying to match a color, and then looking at the number, it's just a lot more work to read this. So again, you want to try to avoid these if you can, unless because they, like I said, they're whenever there's going to be an error in interpretation, it'll be easier for that error to happen if you use a pie chart. So another thing we have to be careful about is a truncated graph. So truncated graph, there's a time when they're very useful, but you just have to be careful because of what can happen. So truncated graph, to see what that means, these two graphs show the same information. They show the same information, but this is truncated, meaning the vertical scale is starting at 8,300. So imagine that you are the sales manager for Group D. You're the sales manager for Group D, and you're going to a meeting with your bosses or with your boss or whatever, and you want to make a good impression. Well, these show the same information. Which one do you think you might pick here? Right? I mean, this, when you're looking here, they look pretty close. When you look here, it looks like Group D is just crushing Group A, which they're really not. They're fairly similar. So you have to be careful with truncated graphs. Now, like I said, there's a time when it's useful because if you really do want to see the differences, you can't really see them here. So if you do want to see the differences, you could use this. You just have to realize what you're looking at. In any graph that doesn't have a vertical axis is a worthless graph. And I've seen them before in marketing. I see them in commercials sometimes, especially television commercials. And if you take, like, by the time you take 2 or 3 stats classes, you can barely stand to even watch commercials because there's just little things like this that are done. A big one is to not even list this. There's a memory commercial that I see every once in a while, and it talks about like memory performance or improvement in memory. However you would measure that is unclear, but there's no vertical axis, so it's totally worthless. You can put whatever you want. So be careful with truncated graphs. Just basically always look at the vertical axis to see what it is you're looking at. Okay. Improper scaling. This happens a lot too. So in this case, we've got some information from USA Today. Here's the original data. Here's actually the better graph. It's just not very pretty, right? But this shows that if you look at this bar compared to this bar, this is about twice as tall. And that's really what you want to show. But what happens sometimes is before these go to print, they will get edited in a way that, makes them look better. I mean, this is more pleasing to the eye, but unfortunately, when you look at this now, this is scaled in 2 dimensions. So the area, not only is the height taller, but it's also wider. So your eye will interpret it as area, and something that where this is twice as high as this, now this has the area that's 4 times the area of this. So you have to be careful. It's not always done to mislead you, but it is definitely done sometimes to show something in the best light possible. And sometimes doing that makes it misleading. And again, sometimes it's just accidental. So just be careful with the graphs. Make sure you look at the graph carefully so you can see what it is you're looking at. But improper scaling, this happens fairly regularly. And let's see, what else do we have here? We've got, this one. This one's got everything bad about it. Number 1, it's a pie graph, which is generally speaking a bad idea. And then to make it worse, it's a 3-dimensional pie graph. So it has this thickness, which then it makes it a bad graph even worse. And then, do you notice something bad with the numbers here? What should these add up to make this even make any sense at all? Should add up to 100. So this is information that definitely should not be put in a pie graph at all. It's basically this, by the time you factor in any margin of error. This is a totally worthless. This whole thing is totally worthless. So I've been told that there's only one good pie chart, and this is it. Right here. The only good pie chart is right here. All the rest of them are best avoided, but like I said, they are everywhere. So that should put you in pretty good shape for 2.2. So remember to really learn the material, you can't just watch the video. You really have to do the homework. There's going to be little bumps you hit along the way that we all hit, and that's how you learn. So make sure you do it. Do the homework. It's super important. And any questions that come up, just let me know.